Nano fam, let's party. We got it. We got it done. We did it. We have RS Nano running on Tokio. The Rust async runtime. We finally did it. Like, this is a huge milestone. Hey, Undefnal, welcome. So, how are you guys? How are you? Like, I'm excited. Like, this week has been really an amazing week. I can't believe it that it works. A huge milestone, and let's jump right into it. But before, yeah, party, hey. That is some great decoration, says LFLF. Yeah, this is from my kids from the last birthday. So, nice ribbons, lol, says Undefnal. Sammy D, congratulations, thanks guys. So, last time I forgot about the giveaway sometimes, so I thought I would do it differently this time. I would use a timer that would remind me for about the giveaways. So let's do the first one right away. Post your Nano addresses in chat, and this time, because I'm tired of typing in your addresses every time, I want to add them to my address book, so that the next time you just say hello in chat and you don't have to paste your addresses every time, and I don't have to copy them every time. So I'm going to add your addresses that you post in chat to my address book. LFLF says your kids are RS Nano fans. Yes, they are. Oh, wait a second. I show you something. My little one, when she eats, you know, I got it as a present for my sister-in-law. Did you see it? Okay, so Nano addresses. And if not, that's cute, cool. So cute, yeah. So let's copy your addresses and let's add them to the address book. So first of all, where's the thing here? Address book. FLF. Then we are adding an end of null. So that will just speed things up in future streams, because that just takes time copying those addresses all the time. So 1, 2, Sammy. Let's add Sammy's address. And I want to also add them here. Look at that thing here. Where is it? This one. Isn't that nice? I've got a spinning wheel because that is much nicer than the random number generator from YouTube. So we have Undefnal in there. We have Sammy. We have... oh, what happened? Ooh, what was that? LFLF. LFLF. Undefnal, Sammy. And let's add the other ones too. Oh, what is this green one? That is too much. So we have add new entry. Welcome to chat. These are some new names, I think. And what else do we have here? This Nano address from this name, hard to pronounce. How to pronounce that name? Okay. So, yeah. So post your Nano addresses in chat, and with a bit of luck, you win 1 Nano. And because we are celebrating the Tokio today, that Tokio works, I'm going to give away 10 Nanos So that is like 1 nano every 11 minutes. And for that, I have a timer here. So let's start it right now. So in about 11 minutes, we will hear a sound, and then we will do the next giveaway. Okay, guys, I'll give you a few more seconds for more nano addresses. And then let's spin the wheel. Okay, no new addresses. Okay, let's spin the wheel. Ready, guys? Let's click it. And the winner is, it is LF. There you go, you won. Let's send you one. Let's send you one nano. Okay, unlock. Oh, lock the wallet. There you go. Okay. LF spinning wheel was so exciting. Yeah, that's much better, isn't it? Like it's the same thing. It's just a random number, but the spinning wheel is just way cooler. Congrats, LF, says Antifnol. Yeah, cool. Okay, so in about 10 minutes we will hear an alarm, and then we are going to give away one more nano. So that's okay. So that was the spinning wheel. Okay, so Tokio works. Let's just recap what happened. Here I drew a diagram to show why this is so exciting. Before this thing that I finished last week, this is how it looked. We had the RS Nano node, and part of the code ran in Rust, and that included most of the networking stuff, like serializing messages, deserializing messages, handling the messages, like what to send back and stuff like that. But the core part, the part that would actually send the bytes out to the other nodes, and the part that would actually receive the bytes from the other nodes, that was still C++. And that was the Boost async library, a very famous C++ library for all kinds of things in C++. And we could say this was the heart of all of the networking stuff. Went through the async runtime, the Boost async runtime. And what we did is, or what I did is I wrote a second implementation, and let's make that green, because green is Rust here. The second implementation was written in Rust Tokio, and Tokio is the most famous async runtime in Rust. And what I did is I basically replaced the Boost runtime with, well, let's send this to the bag. Yeah, so I replaced the Boost runtime with a Tokio runtime. And that basically means is I replaced the heart of all the networking with Tokio, with the Rust heart. So we replaced the C++ heart with the Rust heart. And that is very risky, because those libraries, they behave very differently. And I was not sure whether this would work out well. And it did. And it was not easy, but last Friday was the day when I got it to run. And Andofnal says, Gustav, on Discord you mentioned something about a bug memory leak in this code. Anything new? No, not anything new. So there is still a memory leak, and I can show you that. So what I did on Friday, when it ran, so there was just a couple of minor bugs that I found and fixed, and then the node ran, and I thought, why not start a full bootstrap? Like, a bootstrap is where a new node downloads all of the blocks from the network. And I did that started it on Friday evening with the Tokio runtime, and believe it or not, it actually finished. It went through it. The bootstrap completed in the first try. And I have the data here still in my Grafana metrics, so let's have a look at them. So that's here. Here I started and here it finished. So it took 2 days and 16 hours to complete, which is okay, like for the first run. And as you can see, it didn't go 100% like it should. When you have a look at these two lines, the yellow line and the green line, the yellow line are the blocks, the downloaded blocks, and the green line is the cemented blocks. And cemented means basically they are confirmed and cannot be changed anymore. And those two lines, they should go up together. And for whatever reason, the cementation rate went down here significantly, and I have not found out why yet. So that is still one problem that I have to find. And the other problem is a memory leak, because after those 2 days and 16 hours, my node consumed 9 gigabytes of RAM. And that is obviously too much. So there is a memory leak in there, and there, for some strange reason, the cementation rate went down here. So those are still two problems I'm going to fix. But I'm super happy with the result, really. Like, I would not have guessed that it would run through on the first try, because that change is so massive. I would never have thought that it would actually bootstrap without a real error. And if not, says 9 gigabytes of RAM sounds like Java. Yeah. Java, yeah. After starting the node in Java, it would probably consume 9 gigabytes of RAM. Yeah. Yeah. So that's what we are celebrating today. This is a huge milestone, replacing the heart of our network code with Rust. Means that in the future we will be able to write tools that interact with the network, and those tools can be in pure Rust with no C++ involved, and we can refactor the code now to use Rust's awesome async syntax, because the async support in Rust is just amazing. And until now, we use the boost async stuff, which uses callbacks, and this callback style async is just really hard to write, to read, to understand. And we can refactor it now to use the async keyword and to get rid of all of the callbacks. LFLF says 9 gigabytes sounds like a hello world with JavaScript and Node.js. Yeah. But don't worry, guys. I'm gonna find the memory leak. No worries. Okay. So Tokio works, and I published this on Twitter, and out of nowhere, donations came coming in, and I was so surprised. So I wanted to say thank you again, because like out of nowhere, I haven't counted it, but I think something roughly like 160 nanos of donations from all sizes came flooding in, and I was really, it was, I don't know what to say. Like it was really something. Like, not the money, but just to see the support from you guys. So just wanted to say thank you for that. So that's it. That's the first part where I wanted to recap what happened, and I want to celebrate with you. And I brought myself a local beer for today. It's a Schönbuchbräu, and Schönbuchbräu, it's very close to where I live. And I thought I would what's the word? I don't even know the word. Like, anstoßen is the German word, is where we just celebrate. And I hope you've got something that you like, something sweet or something to drink or whatever. But today is a day to celebrate because I've worked like really long for reaching that goal. So that is like months of work there, many months of work there. And if it just turns out to work on the first try, that's just, yeah, doesn't get better than that. Yeah, LFLF says Prost. Yeah, Prost. So chat. LFLF says, I will raise my glass of water to that. Yeah, it's fine. Raise your glass of water. So also, thank you for watching my stream and supporting me on this journey. So, okay. Sammy D says, I'll get a beer too. Yeah, do that. And write me when you got one. And if not, I have my own tea. Tea, oh, I like tea. Tea is nice. Okay. Oh yeah, and before I start coding. Oh, the time is, oh, that was the alarm. Did you hear it? The honking sound was the alarm. So, oh, 10 minutes, 11 minutes gone already. Let's do another giveaway. Let's reset the timer. Earl Grey hot. Is that from Enterprise? Next Generation? Picard said that all the time, didn't he? So let's spin the wheel. And you guys, if you are not on the wheel yet, post your Nano address and I put you on the wheel. So, congratulations, Ellie, Bob, for 1 Nano. There you go. Okay. Yeah, so post your Nano addresses in chat, and I put you on the wheel. Ellie Bob says, thank you. Amazing. Yeah. You're welcome. So, yeah, before I start with the refactoring that we are going to do today, and this stream I think will be interesting. It's like not like boring bug finding or like just porting stuff that we don't understand yet. This time we are going to refactor, and because this is the Tokyo celebration stream, we are going to refactor Tokyo stuff. And before we start that, just one thing, stream, I wanted to know what you think about what happened to IOTA, because when I heard that, I don't know if have you heard it, IOTA, the co-founder Dom decided on his own that they would increase the supply by over 60%, and he just forced that without involving the community, and he just pushed that. And I was shocked. I was really shocked when I read about it, and I want to know what you guys think about it, because this is really interesting. A similar discussion was in the Nano community. If you were there back then, it wasn't even a long time ago, where there were a couple of people in the Nano community who were very strongly advocating raising the supply. And there were really hot discussions about this. And now IOTA did that thing. And yeah, it shocked me. It shocked me not so much because they raised the supply, which I'm personally like very opposed to an idea like that. Because from my point of view, this is just stealing from the community. I was shocked that was possible, actually. So it was possible that a single guy could actually raise the supply in IOTA. And that shook me, because I've heard, I'm not an expert in IOTA, and I've heard people say that IOTA is a centralized coin. But now it's just obvious how centralized it is. If a single guy can raise the supply by more than 60% without any opposition. And yeah, so that's something that really shook me. And there's some stuff in the chat. Let's see. LFLF says, stuff like that is the reason why many people think cryptocurrencies are scams. Oh, yeah, I agree 100%. So it's a shame. It's really a shame. Underfnall says, there is really no reason for raising supply for Nano. One Nano has like 1 billion raw or so. Yeah. Forrest says, increase in supply of Nano was once proposed by a community member, and I was glad to see that the majority of the Nano community was against this idea. Yeah, so here's the thing. Here's how I see it. The IOTA Foundation has monetary issues. Okay, like many crypto projects. And they decided that they want more money, which is a good thing. Like, yes, of course, foundations should have money, and so that they can pay their developers, and that would increase development and make them more competitive. Okay, I agree. That is a good thing. But increasing the supply means taking the value from the guys that hold the coin. So it's basically stealing. It's basically by force taking value from the guys who put their hard-earned money into it. And it would be actually okay if the majority of the community, from my point of view, would agree. If there was a democratic decision, and in Nano's case, it must be 66% of the vote weight, which must agree to a change like that. And if 66% of the community or of the vote weight would agree with a change like that, I personally, I would like never vote for an increase in supply. But if 66% of the community would be in favor of this, I would go along. Like, this is like just basic, it's democracy, really. But if a single guy decides to increase the supply in secret and does not involve anyone, and he could actually push this through, like, this is just unbelievable. It's unbelievable, really. And it just shows how centralized IOTA is. So what was the last chat message I read? Horst says, increasing supply once also sets a precedent for the future and really takes away the store of value proposition. Oh, that is right, yeah. Sad for IOTA community, to be honest. They are welcome to join our community through... Though, yeah, that's true. Yeah. I think IOTA and Nano, they share a lot of vision. And it is my personal view that Nano does a way better job at this, because as we see, like, IOTA is governed by a dictator. Sorry for the harsh words, but I just see it like that. It's governed by a dictator, really, who does not really care about the community so much. Otherwise he would have involved the community. Underflower says, let's like one guy is changing the rules while the game is running. Yeah. And LFLF says, I think in that case there could be hard forks of Nano. It would for sure split the community. Yeah, I think there would, but Nano is not well suited for forks, really, because of the representative system. And it would, forks in Nano would just be attackable by the stronger fork. So the weaker fork would be attackable by the stronger fork, because the representatives would be forked too, and so a representative of one fork could just attack the other fork. So Nano and forking does not go well together, really. LF says, good point, Forrest, but most are just in to get rich quick. Oh, that is the most disgusting thing, really. But yeah, it's understandable on the other hand, because yeah, getting rich is just something that people want. But most are just, where was I? Just into get rich and not for the tech. Otherwise, Nano would have a way higher market market cap, probably. There is just nothing like it out there. Yeah, I agree. So, and you know, guys, what I found shocking too is I looked at Twitter at how people responded to the supply increase, and to my surprise, a lot of people were shocked first, but then they were still in support of it, and I couldn't understand that really. And Underfnal says, damn, I never thought about the attack vector you mentioned. Yeah, so there is an attack vector if there's a fork. And I think this is a good thing, actually, because it is a very strong force against forks. Yeah, I will have a very close look on IOTA and what happens there. And it's very interesting because there was so much discussion about this in the Nano community, and now we can see how it plays out at IOTA. And the price dropped, for example, but I was surprised that it didn't drop lower. But yeah, so the new supply isn't there yet, so let's see how all of that plays out. But I think Dom, so the guy, the co-founder of IOTA who did all of that, I just think he showed what type of guy he is. And I find it baffling that people still trust him. Yeah. And to all of you Nano guys out there, so with Nano, it would not be that simple. It would not be like one guy could decide to increase the Nano supply, because Nano is actually decentralized. We have the representative system, and for a change like that, you would need support of more than 66% of the vote weight, and only then you could change the protocol. So, and that the representatives are run by the community. So it's not like in IOTA where it is run basically by the IOTA Foundation. So in Nano, we are actually decentralized. So we can sleep without worries there. That action hero, post your Nano address and you can take part at the giveaway. The new supply must be sold to the market to develop. So I assume the price will drop more in the future, I imagine. Yeah, because I read the dumbest things on Twitter. Like there were people, oh, that was the sound from the next giveaway. There were people on Twitter who said, oh, don't worry guys, the new supplies, it will not go to the market. It will just go over the counter, so it will not affect the price. And how stupid is that? Like, of course it will go to the market. Maybe it won't go to the market immediately, but at one point it has to be converted to old fiat currency to pay the developer. So of course it will go to the market, and of course it will push the price down. And Fnal says, dumb things on Twitter? No way. Okay, maybe my expectations were too high. Okay, so it's time for another giveaway. Let's restart the timer and the spinning wheel. Let's go. 1 Nano goes to... Oh, Illy Bob again. Congratulations. Bob, 1 Nano. There you go. Or says definitely creates sell pressure. Yeah. So maybe those people who write that shit don't understand how markets work, or maybe they're just delusional. Or maybe they're just so attached to IOTA that they would just take anything. They would, like in an abusive relationship, would just go back. Yeah, I don't know. So, yeah, I mean, that's just my opinion. Like, is there anyone in chat? Like, I'm open to different viewpoints, really. Is there anyone in chat who has like a different viewpoint? I welcome different viewpoints, so no worries. And that's all by the way, about different viewpoints. I've seen Dom just banning people and kicking them out of Discord just for opposing his ideas, and that's another very dangerous sign. If someone can't take criticism. Bob again, I should play the lottery. Yeah, you should. Okay, so yeah, so if you have like some more things to say about IOTA, post it in chat. I'm really happy to discuss this. Andefnal says, what prevents this IOTA guy to increase the supply during the bull market? Nothing. Yeah, if he can do it once, he can do it again. And he is the one who's getting the money. So the game theory is actually in his favor. So yeah, there are not many reasons for him not to do it. Okay, but let's get back to business. What I wanted to do today is let me open another diagram. This one here. This one here. Can you see it? Let's move to the top so you can see, and the chat messages, they are overlapping this. So maybe let's that one to the top. Yeah, and let's move all of that. Oops. To the side more. Yeah, looks good now. Gravity, hey Bob, how are you? Part of the new IOTA supply has probably been sold to a VC, and VCs typically don't want to lose their money, so they have a vested interest in marketing, in making the price go up. Okay, yeah, that's a point. That's a point, yeah. So a VC, a venture capitalist, would probably not immediately sell them because they want to make money with it. But I think there will come a time where the VCs sell their holdings, and then they are selling coins that, yeah, didn't exist before, and so yeah, it is. Like, I don't know what would happen really. So this is the point. Like there is arguments in favor of this, and I understand that there are a few points that say, yeah, that money goes to the foundation and they make the product better, and that makes the price go up, and that benefits all of the holders. But really, like, there's no guarantee for that, and yes, I don't know. I really don't think that this is such a good idea, and or maybe it is. But what I am very strongly opposed to is that Dom did it without asking anyone, and he just enforced it. Ed said, where is chat? How do I join giveaway? Okay, so come to YouTube or come to Twitch. So, oh, you are from YouTube, aren't you? And just post your Nano address in chat. Yeah, I left that. Just post your Nano address. Here on YouTube, yeah, here on YouTube. Oh my god, so many messages. Okay, so there's Ed's message, so let's add him. Let's add him. So you're now on the wheel, Ed. Okay. And the next giveaway is in 5 minutes. Okay, so yeah, so back to Gravity's comment. Yeah, so there are arguments in favor of it, and I am undecided about them. It could turn out well, but for that, the increase in value must be like a lot bigger than the supply increase, and the supply increase is like more than 60%. So it could go well if that money would actually like make IOTA go up in price significantly, and the VCs won't sell soon. But yeah, so my main criticism is that it was decided by just one guy and enforced by this one guy, and that he could actually enforce it, that there was no decentralization there that prohibited him from doing it. So Forrest says, streaming it on Perceive again as Faucet Stream too, so I'm giving away Nano as well. Cool, thanks Forrest. If people want to join from there, earning for watching, cool. Yeah, so go to Perceive and you can earn some extra nanos there. All right. Okay, let's go back to the plan for today before the next giveaway comes. So this is what I wanted to start in this stream, and we will not finish it in this stream. This is like a longer term thing we are going to start today. And my plan is for the next streams to work on this and not to port any more code, because from my point of view, I've ported enough on stream and it's always the same thing, and I think it's boring. So if you are interested in how to port, you can just watch the old streams. And I want to focus the next few streams, or maybe even the next many streams, on refactoring, because for me personally, refactoring is way more interesting. Forrest says, might be fine if sold to VCs for short term, just when it comes to market sell pressure, but in long run, increasing supply will definitely have effects. Yeah, LFLF says, great job, Forrest. Can you donate to the stream too? Can you donate to the stream too? Alberto Rojas, how can enter a giveaway? Just post your Nano address in chat. Gravity Dev says, IOTA is an interesting project for sure. However, I would not put my effort into a decentralized network where one person can just increase the supply like that or stall the network. Yeah, I agree. LFLF says, the Perceive stream. Okay, so yeah, where was I? So all the new viewers, post your Nano addresses in chat, and you take part at the giveaway. So this diagram on screen you see right now, this is what I want to start today and keep on working over the next streams. The central thing here that bothered me for quite a while is the class, or Rust doesn't have classes, the struct message deserializer. And I want to make it green so that it sticks out. Alberto, yeah, your Nano address. Let's add it. Ooh, what is that? There's an... Is that a 1 at the end of your address? It is like, what's the name? It's raised? Okay, add new entry. Alberto. Is that like that or with a 1? Yeah, okay, I guess that's it. Okay, and then let's add a new entry for Forest. Okay. And back to the diagram. So message deserializer is a struct that takes bytes from the network, and it parses those bytes, converts them into messages. So messages that just nodes exchange, like new block here, new vote there, whatever. There are many types of messages. And the message deserializer just takes a byte stream, and it reads the bytes, and it creates messages out of those bytes. Oh, another giveaway. This 11 minutes they go past so quickly. Okay, let's reset the timer. Let's spin the wheel. Oh, wait a second. I have not added Forest. Oh, I forgot. Did I forget anyone else? Forest? Alberto? I think I forgot you. Yeah. Okay. I hope I haven't forgotten anyone else. Yeah, many giveaways today, Sammy. Let's go. So, this is unreal. Haley Bob, you won again. All right. Why not? Send another one. There's more, guys. Don't worry. There's more nanos. We still have... Ooh. Did we get a donation? Why are there so many nanos in here? 10 nanos. LF, you sent 10 nanos. Thank you for that. That's crazy. Thank you. And we still... And 7 nanos. Ooh, thanks for the 7 nanos. I didn't see. Oh, that's nice. Thanks so much, guys. Okay, so... Okay, we got time. So the message deserializer, taking bytes from the network, converting the bytes into messages. And now look at that ugliness here. How does it work right now? It reads the bytes from the type read query, and read query is just a type alias for this monstrosity down there. Can you read it? Let's make it bigger. Can you see that? Can you even read that? This monstrosity down there. I moved that from C++ to Rust, and I had to extend it into that thing that it is right now. It is a boxed in fn arc mutex vacuate blah 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 blah, and it doesn't stop. And what it does is it is a callback function, and a callback function that basically means a function that, can you see that? A function that takes a buffer and a len. So that buffer is written into, and the len is the amount of bytes to read. And then it takes a callback, a finished callback. And that finished callback is called when the reading completed. And this is basically the design from the C++ node. I just had to like make it a lot more ugly to make it work with Rust. And yeah, and this is Colin, hey, welcome. Colin is laughing. Yeah, LFF says, I love Rust, but writing out these types are just crazy. Yeah, I thought I would write out the type just that you see why I hate this so much. And, yeah, so this is just a monstrosity, and I want to get rid of it as soon as I can. And I couldn't get rid of it as long as the async runtime was boost, because boost works with callbacks, and as long as we used boost, I had to have this callback stuff in there. But now I have Tokio, and Tokio doesn't work with callbacks. Tokio has the await keyword, and it manages all of the state itself. So my long-term goal for the next few streams, for the next couple of streams, is to get rid of this boxed in argfn whatever blah blah blah. Yeah, and what I wanted to do is I want it to directly use Tokio streams, where we could just await for the bytes to arrive, and then the code would be much cleaner. So that is the goal, guys, and this will take some time because we can't just start the message serializer. So I drew some more boxes here. You see who uses the message serializer. It is mostly the TCP channels class, which is yeah, like the TCP connections to other nodes. The TCP server, which every node runs, which accepts incoming connections from other nodes. So that one too uses the message deserializer. And the channel inproc. And channel inproc is a channel, or it simulates, you can say, it simulates a TCP channel. And it is mostly being used in tests where the tests, they don't spin up real TCP connections, but just an inproc connection, because that is faster and less error prone. But I found places in the production code where channel inproc is used too. Not many, just like maybe even just one. But it is used in production too, I think when the node sends something to itself or something like that. So these are the 3 places where the message deserializer is being used. And so they create this boxed in FN blah 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 blah, and internally it points to the socket, which points to our TCP socket facade trait, which I had to introduce to gradually move from Boost to Tokio, which has one implementation, the Tokio socket facade, which uses the actual Tokio TCP stream. And as you can see, this is just way too much. That many levels of indirection is just bad. But it was necessary for me to gradually move the code to Rust. But now that we have Tokio running, I can get rid of all of those things here. And I want to simplify it. I want the message deserializer basically to work with the TCP stream without so many intermediaries. And then finally to get rid of this monster, this boxed in FN arc mutex vacu8. Oh, we got a new Nano address. Let's add that. To node addresses. The name is Andrew. And let's add it to the spinner. Okay. Okay, so that's the long-term goal for the next few streams. And I thought I would start this stream with just the Tokio TCP stream. So just this box up here. So let's delete everything else, because we have to start at the lowest point so that we can use the await keyword on higher level classes. So we have the Tokio TCP stream. So this box is orange because it is not from us. We use it from the Tokio project. And just 1 second. So what I wanted to do is I wanted to make this TCP stream nullable. And if you are a regular watcher of my stream, you know what nullability means. It is something I'm a huge fan of. It is from this article from James Shore, Testing Without Mocks, a Pattern Language. And in this pretty big article, it's a small book actually, James Shore introduces his way of testing systems without using mocks and without using the real implementations. And this system is like so cool because it makes the tests run really, really fast, and they are very stable, so they don't fail randomly as integration tests often do. And so watch my older streams or read this article if you're interested in these techniques. It has many, many advantages and very few disadvantages. I'm a huge fan of this, and I want to use this technique on the TCP stream to make the TCP stream more testable, because I want to write unit tests that simulate all types of errors like connection losses, timeouts, and so on. And I want to do this without using a real socket. I want to use it with a nullable TCP stream. Oh, and we have another address here. Add it to node. So this is Sergio. And here too. Okay. And it works like that. We have the message. Let's simplify it. Let's say we have the message deserializer. deserializer. So this is like a new design idea where the message deserializer would just directly use the Tokio TCP stream. And this is not enough, because now when I want to write unit tests for the message deserializer, I have to use the real TCP stream, which means I have to actually use a real socket. And I don't want to do that. So, oh, Nano giveaway. Did you hear it? Let's spin the wheel. And who is the lucky one? Who's the lucky one? Yeah. Congratulations, Pies. I don't know how to pronounce it. Oh. Send. One Nano. There you go. So this would not work because, yeah, I don't want to run a real TCP stream. So what can we do here? That we are going to use the nullability pattern from James Shore. And nullability means, so he means with nullable that we use production code that can be turned off, where the infrastructure part can be turned off, and the infrastructure part is the Tokio TCP stream. So we are going to add a struct into our Rust code that also is called TCP stream. And this TCP stream will delegate all its calls to a trait. And oh, I don't know how to name it. TCP stream. I just say trait here. We will have to find a better name. So this is a trait. A trait is an interface for all the non-Rust guys. So this delegates all calls to this trait, and there are two implementations. A bit higher. There are two implementations of this trait. There's the real implementation, and this is called, we call this a Tokio TCP stream wrapper. This is the real implementation, which just delegates all of the code to our real Tokio TCP stream. And then we have another implementation, the TCP stream stop, which is an embedded stop, which just which can be configured to return whatever we want in the tests, and those classes, so the trait and the wrapper and the stop, they are all hidden. They are all internal, so we never see them. We only work with the TCP stream, and the TCP stream, it will have two methods. It will have a create for creating it, and it will have a create null method for creating a nulled version of the TCP stream. And again, nulled version means it is a TCP stream where the part that actually sends bytes to the network or actually receives bytes from the network is turned off and is replaced by this embedded stop. And this is the pattern. This is the nullability pattern that I want to start today. And with the goal of making this, all of that testable. Okay, in chat, 5x says, hey, oh, we're doing testing. Yeah, we are. We are going to refactor the new Tokio stuff to make it testable. And then we are going to refactor the message deserializer. But this, we will not even get close in this stream. This will be something that, yeah, will keep us busy for the next couple of streams, I guess. 5x says, I'm actually writing some integration tests at the moment. Are you? Cool. Yeah, then this article is for you guys. If this is your type of work and you write integration tests, or if you work with mocking frameworks or mocks a lot, read this article. It is a very different approach And from my experience and from my viewpoint, it is just way, way better. It is way better than writing integration tests, and it is way better than using mocks. Because mocks, you never know if the mocks behave in the same way as the real system. And it can be that your tests are green because the mocks just don't behave like the real system. And if you run the real system, it crashes or it has a bug. And this article here describes how you can write tests and your whole code in a way that it uses the real production code in the tests without actually using infrastructure. What's new in the chat? DMAA says, amazing job, thank you. Vivek says, what? Mocking? Hell no, I'm running a browser to run my tests in. Okay. So. So where, oh, did I restart the timer? I didn't. Start. Okay. So this is the goal. This is what we're going to do. We're going to make the TCP stream nullable, which means we make it so that we can turn it off. We can turn off the actual reading from the socket. And that action here says, Gustav looking sharp on the LinkedIn picture. I have a, oh my god, I think I have a LinkedIn, but I think I've never updated the picture in 15 years or something like that. It says writing a web framework, so running a real browser feels important. Yeah, okay. There's points to that, yeah. Okay, but we don't need to run our tests with real sockets. So where to start? We want to create a nullable TCP stream. And I've never done that before, and I've never done that before in Rust. So I don't know how this will end up. Let's see. So here's my new IDE, NeoVim, introduced it like 2 streams ago. And we wanna add a nullable TCP stream. So this goes into Rust node, and where is a good place to put it first? We don't actually, transport here, transport is a good place, because transport has the socket stuff. So let's add a new mod here, and let's call it TCP stream. And can we create it from here? Does that work? No, it doesn't. Oh, it does. Create module TCP stream. That's cool. And inside here, we create a struct. No, we start with a test. Almost. That's gonna almost started with production code. So we start with a test, and so where can we start here? Should we start with the real implementation? Should we start with the null implementation? I think we should start with the real implementation, and later on we should try to make it nullable. And maybe I should start with so there are integration tests with this testing without mocks pattern, but they are very, very focused. So there would only be a handful of integration tests that would use the real TCP stream from Tokio, and those tests would only test if our wrapper would delegate the calls correctly, and that's the only thing they would test. So those tests are very, very small, very few tests of them, and so they should not slow down our test cases a lot. Okay. Oh, we have a lot of viewers today. 12 on YouTube and 2 on Twitch, says my chat. Okay. So, how to start? I don't even know a test name, so let's just sketch out something. I want to create a new... It says, I think giveaway timers off. Just reminding, is it? I know it is running. I forgot to restart it and I just did. I want to create a new stream. And I want to use my version of the stream. And I have to give it the Tokio stream. So this has to be Tokio test. It's an async test. It's an async. So what you guys see here is the async, is the way how async code is written in Rust. We have the async keyword, which just tells us that this function is async. And inside of an async function, we can use the wait keyword and run other async methods. Vivek says, yeah, my test suite isn't that fast, but again, it is important to run in a real browser. And I do share the same browser session across all the tests, so that avoids a good amount of slowdown. Yeah, so if you're running if you're creating a web framework, yeah, I agree that there should be tests. There should be tests that run in a real browser. Yeah, I agree. But what I often see is that way too many tests are run on real infrastructure, and that could be not saying that it is the case for you. It's just like my general experience. I've seen that a lot, that tests run on the real infrastructure, and most of those tests could be refactored to not use the real infrastructure or not to use any infrastructure at all. And that is also what James Shore is proposing in this pattern language. He says that there should be, can we scroll down? There should be a very hard separation between logic, he calls it logic. Let's just draw the diagram. Logic. So logic is the rules, the behavior we want to test, which does not involve infrastructure. And there is on the other side infrastructure, and infrastructure structure in his definition is anything that talks to the outside world. So outside world can be many different things. It can be the network, it can be the disk, it can be the system clock. The clock is outside world, and yeah, there's so many different things that is considered infrastructure. So everything that lives outside of our program. And the way why he makes this strict separation here is because all tests that involve infrastructure are difficult, because infrastructure is hard to simulate. It is not reliable, because sometimes you can use a network port and sometimes the network port is blocked by another process, for example, and that just makes the tests flaky and slow, very slow, if the tests use the real network or the real disk. So infrastructure tests should be minimal because of that. And so this is what he proposes. He calls it the A-frame architecture, and he has these 3 blocks: application, logic, infrastructure. And logic is just pure logic. Think of this like functional programming, just functions, not involved with infrastructure. And infrastructure is a very thin layer where just the infrastructure is implemented, and on top is the application layer, which does connect both. So the application layer is not very big. It just like reads from the infrastructure, then passes the data to the logic. So what you would see here is, for example, stuff like that. Let's put it here. You could see something like file is, oh, let me move that down here. So you could say like a file is like read file something, then process that result like is equal to do something with the file, with file, and then we write the results back. So this is what you see here. These 3 lines is what would be in the application layer. So the first line, read file is infrastructure, it would read the file. The second line, do something with file, would call into our logic. And the third line would write the results back to the infrastructure. And all or most of our unit tests would be in the logic part. And those unit tests would be really easy to write, because there is no infrastructure involved. It is just like functional programming. You would give data in and you would receive results back, and you could just write tests very easily. And this here James Shaw calls the logic sandwich, I think, because the logic is in the middle and it is a sandwich with infrastructure on top and infrastructure below. And sorry, with this style, I wanna keep the style because it is very simple and it makes testing easy. So let's have a look at what's new in chat. Oh, and let's do the next giveaway. So IO tests, Vivek says, IO tests are always tricky to write. Either you run on real stuff or you do mocks, which have the issues you mentioned. But logic should be super simple to test basically anywhere. Yeah, I agree. Oh, the ports are annoying. My tests use 3 different ports when running. Yeah. So that was just one example of how infrastructure tests can fail. And there's many, many more. For example, like your test creates a file and the file does not get deleted, and on the next run the file already exists, and that makes the test crash or fail. And so there's so many ways a test can fail. Yeah. Okay, so the next giveaway, let's restart the timer and spin the wheel. 1 nano goes to Sergio. Congratulations. There you go. Okay. So that was our course. Congrats, yeah. So that was our short introduction into A-frame architecture. And this is an architecture that is just simpler than hexagonal architecture. I was a huge fan of hexagonal architecture, and I still am a huge fan of hexagonal architecture. But A-frame architecture achieves the same thing with less code. So it is simpler, and I like simplicity. So I want to try A-frame architecture first. Okay. Back to our code. So this will be an integration test here, because I want to test that the real TCP stream implementation actually works. So for that, I want to start a TCP server. And okay, how can we do that? I have no experience with Tokio so far. So how to start a TCP server and I think I have a test like that already in TCP in socket RS. And this was a very quick test that I wrote for me, and it's not run actually. It says only run manually. This is where I did my first tests with the new Tokio runtime, and that was also my first time I actually worked with Tokio networking, I have to say. My first time with Tokio networking. And I think we can just copy stuff from here. How is a server started? There must be code in here. Tokio socket that starts a server. Async read. So this is just really ugly code. Ignore all of that. This is the current glue layer, which emulates the boost behavior on Tokio. And this is just really ugly code because I wanted to get it to run first, and all of that will be deleted anyways. Where is the part where we start async accept? I think this is it. Listener. Yeah, we need a listener. We need... How to get the listener? Async accept? No, we need an open. Open call, post, dispatch. Is open? Open. Open. Here's open. So we have to say listener. We have to say TCP listener. Here it is, finally. TCP listener dot bind and an endpoint and then an await. So TCP listener. TCP listener. Use Tokio. Where is TCP listener? TCP listener? And Tokio net. Okay, so let's use Tokio net. And then we can say no, let's I'm just worried about naming conflicts, but maybe we won't have one with TCP listener. So TCP listener accept, and no, wait a second, it wasn't accept, it was bind. Bind, and this takes a socket address. It takes a socket address. So socket address, new IP address. Oh, let's import that one correctly. So localhost. Is that a constructor? Yeah. And the port, which port? What's the port range I can safely use here? Chat, do you know? I just pick whatever port. Dot await. So this returns a listener. And maybe I should Google an example of how to use Tokio TCP listener. So what I want to do, maybe I should say what I want to do. I want to run a real TCP server. And then in my test, I want to connect to this TCP server and receive some data. And then I want to assert that I received the correct data. That's what I want to do. So here's TCP listener. Okay, we do a bind, then there's, what is that? A loop. Accept, process socket. What is process socket? Do work with socket here. Okay. Then let's do this. Let's accept returns a socket. I think we have to spawn this one in a new. What does spawn take? Future t future. So we spawn and we say listener dot listener accept. Await. And this returns a socket and something else. What's wrong with this one? Expected one argument found 4. How to write Tokio tests. Expected one argument found 4. Consider importing one of these items. What? I don't know how to write Tokio tests. Let's Google for that. Yeah, that's how I did it. Tokio test. Single threaded. And this must be an async FN. Ooh. Real server. Failed to resolve TCP stream. Let's comment this out because this doesn't work yet. And consider using to unwrap result expect. Oh, okay, this is also running. You know, chat, what could be the issue here? Maybe let's just not spawn it right now. Let's do it one after the other. Let's do it like they do in the example. So we what is wrong with the unwrap? Bind listener is that the same version? Yeah. So we do a TCP listener bind and then await, and this returns an IO result. And what did I say? I say bind. Oh, this has to await unwrap maybe. Yeah, okay. Now we got it, and there is remove the extra arguments. Where are there extra arguments? IPv4 address. Oh, this doesn't work like that. IPv4 address. New. Yeah, this was also wrong. 127.0.0.1. Yeah, this looks better now. Let's give away one more Nano. Ooh. Yeah, so what do you guys think? Is this what we're doing now? Is this interesting? Any suggestions? What do you say? 1 Nano goes to Andrew Nakagome. Congratulations. Andrew. There you go. So we have the listener, and then we say accept, which gives us the socket we accepted, and Yeah, Forrest says, congrats, Andrew. And then we say socket dot. What do we do? Do we send or do we receive? So what should the test do? Should we accept the connection and then receive data from the connection? Or should we make a connection and then receive data back? Yeah, I think we should make a connection and then receive data back. So what this one should do, it should send... What is socket? Socket is a TCP stream. So this has a try write. So we have to wait until it is writable. So we have to say loop socket.writable await. So this awaits until... What does it return? It returns an IO result. So this waits until the socket is writable. And it returns an OK when it is writable. And then we can exit the loop. And it returns an error. So this is from the documentation. The try write. We can just copy that. TCP stream. Try write. Here it is. Try write. So here, yeah, so we can just write hello world. Yeah, that's a good idea. Let's try write hello world and wait for the socket to be writable. Okay, so I think we don't need to loop here. We just say wrap. So this is just a test. I don't really care about handling errors correctly. This should not fail. So we wait until it is writable. And then we say, like in this example code, we say try write. Maybe we can just copy that. We say this one. Copy. And so we write hello world. Oh, I have to add the loop. Where's the loop? Oh, the loop is in the writable. Okay. So we have to add a loop. We have to add a loop here. Okay, and then here we break. And here we write hello world. And here we have to say import IO error kind. Import IO error kind. Cannot find value stream in the scope. Stream is socket. Consider awaiting on the future. Yeah, there's an await missing. And the last thing is, if there's some other error, we just say panic unexpected error. So, okay. So this is our TCP server. LFLF, to answer your question, I think the stream is quite interesting and I love that so many people joined. Yeah, I'm super happy that so many people joined. So most or almost all are from YouTube, but that makes sense because I think I only post the YouTube link. And Twitch is not very busy. Ed says, for me, This is way too complicated. I can fix cars, engines, gearboxes, but I'm clueless what you're doing, just watching because I'm really interested how cryptocurrency works. Yeah, but for me it's the other way. Like if my car doesn't work, like I'm I don't know what to do. Andofnal, hello from Twitch. Yeah, I think Andofnal, you're the only one from Twitch, is that right? How many viewers are on Twitch? So okay, we got, yeah, just you, yeah. So we got a server running. 5x was there too? Oh, he was also from Twitch. Cool. Yeah, so like just Twitch is, I think I'm at the bottom of the page, and you only get discovered when you have like viewers. Yeah. Forrest has got 2 people watching on Perceive besides me. Oh, that's also cool. Hello to the viewers from Perceive. It says watching and learning from the best. Oh, thank you, man. Thanks for streaming. Yeah, this is fun. I really enjoy streaming. And time flies by. Like, it's almost 11 o'clock in Germany. So half an hour left and we have not written any code, or not much. Okay, but okay, so this is the server. So then this is the only test that will be really messy, because we are actually running a start a TCP server here, and we have to move this looping code into a spawn so that it will not make our tests stuck. So I don't know if this works. So this will also you be watching me learning Tokio, because as I said, I'm not very experienced with Tokio. Okay, so we want to move all of that into its own task so that it does not block our test from progressing. So this starts the server waits for a connection. When we receive the connection in this line, accept, we wait until that stream is writable, and then we just write hello world, and that's it. Then we just close the whole thing. Forrest says, I also really enjoyed the conversation about IOTA stuff. Yeah. So guys, if you have any more things to say about IOTA, I'm happy to discuss it with you. Okay, so this is the server. It's running now. And now I want to connect to this server with how to connect TCP listener. TCP listener. How does it work? No, not TCP listener, TCP client. How does it work? TCP? No, there's no class called TCP client. How to connect TCP? How to connect to a TCP server? Ah, TCP stream connect, like that. Okay. So let's copy that and paste it here. Oh. Oops. Here. Again. Sorry, I made a mistake there. Copy that and paste it there. So this is now our stream where we connect to localhost and port 8080. What port did I pick up there? Was 50,000, I think. So this test already, it can fail if port 50,000 is not available. So that's why I don't like integration tests. So here we connect to the server. And then... So at the end I want to assert. And so let's just test if what we've written so far works. So 1 + 1 = 3 should fail. So this should now execute all of the code we've written, and then it should fail with 1 + 1 is not 3. So let's see what happens. Let's go to Rust, and let's go to Node, and let's say run our tests. And after the test finishes, we are going to do another giveaway. Come on, compiling. Oh, it couldn't compile. Use of undeclared type TCP stream. Oh yeah, we have to import Tokio TCP stream. Okay, again. What else doesn't work? Could not find test in Tokio. Could not find test in Tokio. Do I have to enable a feature flag for this? Test in Tokio. Tokio test. Is this... why doesn't that work? Tokio test. Do I need a feature flag for Tokio test? Ooh. Wait, do I have to import something? Tokio could not find test in Tokio. What could be the issue? I think I have to add a feature flag. But which one? What features do we have in Tokio? RT multi-thread, net and time. Available on crate features RT and macros. Oh, we don't have macros. That's it. That was the problem, I think. Yeah. Okay, the test failed, and it failed for the right reason. It says 2 is not 3. So it could actually start the TCP server, and it did not fail with that. So that's good news. So let's spin the wheel. 1 nano. 1 nano goes to... goes to... That's just unreal. Like, that's the 4th nano. Itty bomb. Is this wheel broken? There you go. Okay. So looking good so far. So we spawn a real TCP server. We make... LFLF says the game is rigged. And no, you have to try the lottery. Yeah, so I'm not sure why the wheel picks you, but that's just, I think it's just part of randomness. Congrats, yeah, LF. Okay, so we have a TCP connection. And now let's read from that stream. How to read from a stream. TCP stream. Try read. Here's the example for try read. We have the loop. We need a buffer. Let's just copy this. And let's paste it into our test. So we say we wait until the stream is readable. We have a buffer here. 4K is way too big for Hello World. So let's just make this buffer smaller. Let's just make it smaller too. That's also 128 is also too big, but who cares? We've got enough memory. Yeah, let's unwrap this. We have the buffer. We say try read, where we read it to the buffer. This first part, when we read 0 bytes, I read about this already, means that the connection was closed and is not available for reading anymore. And this will be called if we read successfully. And yeah, would block should continue. And if there's any error, we just panic. Unexpected error when reading. And so now here in the OK part, where we read bytes, I think we can just assign them and break. Let's see where this leads us. Let result, let mute, so this will be mutable. Let mute result. No, wait a second. We have the result, it is the buffer. We have the buffer already. So we just have to assert now that the buffer okay, I want to make this simpler. I don't want to say send hello world. I want to send just 1, 2, 3 as numbers. Async write takes a buff. So this, I just want to say 1, 2, 3. The numbers 1, 2, 3. I want to send them. And our buff will be just 3 bytes. And then I assert that what we received is equal to 1, 2, 3. And that is the test. No more errors here. Okay. What do you guys think? Will this be green or not? Did I restart the timer? Oh, I heard. Oh, no, I didn't. How late is it? Oh my god. The tests are green. Would you believe it? The tests are green. So all of that works. And this test now does not test any of our code. It just tests Tokio itself. And now we have to modify this test so that it does not test Tokio code, but that it would actually, yeah, LF, the sound of green. Yeah, I have this sound that plays whenever tests pass. Let me just run the test again so that you can enjoy that sound. Hear it? Okay. So, so that is good. It's green. So what we have to do now, always green, yeah. So what we have to do now is this part, which just uses Tokio. We don't want to write tests for Tokio, obviously. We want to now use our TCP stream class that delegates all of that to Tokio. And Ed says, even I enjoyed it. And so you want to hear the sound when it fails. So let's add a 4. And now let's run the tests. Did you hear it? Dum. Oh, I have to fix this test script so that it does not wait until the playing of the sound is done. Like that. Yeah, now I get back immediately. And not the evil red sound. And now guys, watch this. I have this other script. It's called watch tests. And this is now like I usually work. This now watches for file changes. And it reruns the tests when I save the file. So now I save the file. And I hear the sound. And I don't even have to look at the tests. I hear the sound and I know that it's green. Ed says yes, and it sounds worse. Green is better, yeah. Okay, so now we have to wrap the TCP stream with our own implementation of TCP stream. So for that, I want to undo the import of TCP stream and instead say Tokio. I want to be explicit here so that I know which one is my TCP stream and which one is the one from Tokio. Okay, no errors. Oh, did you hear it? And now let's introduce our wrapper class. And we call this also TCP stream. Abstract TCP stream. And TCP stream will have a Tokio stream. Tokio net TCP stream. And we will just take it. Oh, sorry. We will just take it from as an argument when we construct our stream. So down here, now we want to use our stream, so we just say TCP stream. And no, wait a second. This is the Tokio stream. So let's rename this to Tokio stream. So that's didn't that work? New name, Tokio stream. No file available to rename? Why doesn't that work? Okay, let's do it manually. Tokio stream. Tokio stream. This has to be mute. Okay, so this is the Tokio stream. And now we create our stream. So TCP stream, new, Tokio stream. Just thinking, is this a good idea? The original has a connect method. And ours will just take the existing stream. Yeah, it can't be that wrong. Let's just progress from here. And then we need the readable. And we need the try read function. What's some error message here? Failed to resolve. Use of undeclared type TCP stream. Okay, we have to import. Super. And now Tokyo stream and stream. So there is no one of the expressions fields as a method of the same name stream. We need a readable function. So pop-up and readable. And it's an async function, and it returns a, does it return an IO result? Cool. Is that the correct return type? And for now, let's just delegate directly to the stream. This will change, of course, in the future. Self.stream.readable. Okay, this returns. I think this returns mismatch types. Expected result bool. What does it return? IO result. Oh, it doesn't return a bool. It just returns. It just returns void. Okay. And try read. So the next thing we need is try read. And this takes a buff, U8 buffer. And this also returns a Tokyo IO result. No, this returns the number of bytes read, right? So here we say, so we just delegate it to the stream. And this will also change soon. Remove the await. Oh, this is not an async function. Okay. Okay. Green. Okay. You guys are probably wondering where I'm heading at. It's like, why am I doing this? And let's just quickly recap what I'm trying to build here. I'm trying to encapsulate Tokyo, the real Tokyo TCP stream. Let's delete that. I'm trying to encapsulate this orange box down here, the real Tokyo TCP stream, with this box up here, which is a very thin class. It will just delegate all calls either to our real TCP stream or to an embedded stub, and we will use the embedded stub in the tests. And this TCP stream will also get inbuilt observability. So this will also contain a method like, for example, track writes. And with that function, we would be able to get all the bytes that were written to the stream in the unit tests. And this traceability, this observability would be part of the production code, and it would not be part of just a mock that is just being used in the test. So this is actual production code being used in the test. And this observability does not come at any additional costs, because I'm going to make it optional with feature flags, so that it won't decompile if you don't want it to. And what we just did was the very first step. Let's add another color here. So what we just did was we added this TCP stream class, and we added a direct dependency to the Tokio TCP stream. So the blue arrow is what we just did, and this won't stay like that. We will now introduce these parts here, the trade with the wrapper implementation, and then the stop implementation. And the stop implementation is the interesting part, because that will be used by all the other unit tests in the future. Okay, so where are we and how much time do we have? Oh, I did not restart the timer, but that's not too bad because we are almost at the end of the stream. And how many nanos do we have left? There were 10 nanos in the account. Oh no, I got donations, so I can't take the balance. So how many nanos did we send? 1, 2, 3, 4, 5, 6, 7, 8. 8. 1, 2, 3, 4. Again, 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 nanos left to give away. So, and we have 7 minutes left. So let's give away the last 2 nanos at the end. Okay. What is the next step? So this, I'm really happy with this test, because it works. it is pretty ugly. Maybe we should refactor it a bit. Maybe we could pull out the server part. Should we pull out the server part here? Can we do that? I think we can. If we would just move all of that out here into a helper function. Can LSP do this? Let's see. No, it can't. Oh, okay. Okay, then let's write a helper method by, and let's say async fn start TCP server, test TCP server, and we move all of that into our helper function. And maybe we make the socket address an argument. Like that. And then we say endpoint here. And then in the test, we just call our helper function start test TCP server. This is the socket address. Can we move that? Can we move that into endpoint, into helper variable? So we give it into here, and we say bind here. Yeah, looks good. Unused implementer of future. Oh, there's an await missing. Okay, so the test failed. Did you hear it? Panicked error. Address in use. Ah, this is what I was talking about. Address in use. So the 50,000 port was in use. It's still in use. Why is the address in use? Maybe let's take another one. Let's take 80. But I think 8080 is in use on my computer anyway, so 8088 maybe. Why is it failing now? Address in use. Did I mess something up with the refactoring? Do you guys know how I can see which ports are in use on my machine? Something with netstat. Oh, I don't know that. That can't be used. Why is the address in use? Oh, because this one. Because I bind it twice. I didn't delete the old code. I'm so stupid. It's late. Sorry, chat. It's late. I didn't delete the old code. So it tried to start the server twice. Let's make it 50,000 again. Or is that, should I take like a lower port because the lower ones are reserved? Okay, so oh, there's new stuff in chat. I didn't know. Ed says, I would say volume is a bit on the low side, but when I'm in room alone, I can hear you clearly. Just saying for future streams. Oh, is my voice too low? Okay, I will rewatch the stream. Inviting BP says, hi, I want to offer promotion of your channel. Da, 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 da. No, thanks, man. LF. Oh, gave me hints with the port stuff. Okay, thanks. Damn Twitch spam, yeah. Sound on Twitch is fine, says Underfnall. I'm rewatching the stream just to make sure that everything is okay. Ed says, my phone is on max and still hard to hear you comparing to other videos I watch. Okay, yeah, thanks for the feedback. I will see what I can do. So now we have the helper method here that starts our test TCP server, and now the test became a lot smaller. And I think this is a really good place to stop. We did not get much done today because we talked a lot and all with the giveaways, but that's okay. It was more a celebration stream than a work stream. We have 2 more nanos to give away, so let's do that now. Are you guys ready? Let's go. 1 more nano, 2. Forest, yeah, you deserve that, man. So where is my wallet? Send to Forest. Send, and one more. Underfnall, yeah, you deserve it too. Like everyone deserves it. Like I'm so happy, guys, that you watch this. Underfnall, 1 more for you. Underfnall, 1 more for you. So, congratulations. Okay. That was the Tokyo celebration stream. We did a little bit of work today, not much, but that is the plan for the upcoming streams. I want to make TCP stream nullable, and then I want to use the nullable TCP stream in the message deserializer, and I want to make the message deserializer yeah, look good. Like, I want to clean the code up. The code is just horrible right now. And just let me just bring this up one more time. Which one is the right diagram? I think this one. Let me just bring this up one more time. Here it is. Oops. Did it work? Okay. Doesn't matter. Doesn't matter, chat. The diagram is gone. Yeah, so that will be what we are. Yeah, this is the plan, what we are going to work on for the next couple of streams. Make TCP stream nullable. Massively refactor all the places that use the TCP stream, and make this horrible boxed in whatever callback thing go away from the message deserializer, and make all of that code nice and clean, and write some unit tests for them. LFLF says, was fun as always. Thanks for the great stream and congrats again on the migration. Thank you, LFLF. Thank you so much. Sergio says, thanks, it was fun. Yeah, thanks, Sergio. It was fun. I hope I see you again next week, Tuesday, same time. And yeah, then we are going to continue working on the TCP stream. If you haven't joined our Discord and you want to talk about RS Nano, or maybe even you want to help, go to rsnano.com, and if you scroll down a bit to community, if you go, this is rsnano.com, if you scroll down a bit to community, there you find links to everything, to the Discord server where we can discuss the development, and to the source code. So yeah, join our Discord server, and if you're on YouTube, please like and subscribe to this video, to this channel, I mean. Yeah, and we will see you next week. Forrest says, it was a great stream, Gustav. Thanks for the fun time and all, and congrats again on the Tokyo migration being so successful. Thank you, Forrest. Yeah, I'm really happy with the Tokyo migration, and that was the most difficult thing, and now everything will be better and faster. I mean the development, not the node. Okay. Guys, see you next week. Bye bye.